we have invited here the UC Berkeley Solar Vehicle team. They're an undergraduate solar car team that I was a part of when I was in college, and then I think they build cars. They do like other great things, and then here's Mike. He's gonna give the presentation.
Hello, everybody. My name is Mike Vogel. I'm the team lead for CalSol, and I'm here today to tell you about our solar car team and all of the great experiences that go down. So I'm going to start by starting with the beginning. Car started in 1990 with California Dreaming, and these are all of our cars that have been built since then. We are now on our 7th car, which you'll see in a minute, Impulse. And so that car, which started in 2010, was built over about 2 years and has now raced in both Australia and America. So the first race that we went to was the World Solar Challenge. And that was a 3,000 kilometer race from Darwin in the Northern Territories to Adelaide in the South Australia. CalSol placed 20th out of 37 teams in the week-long race. And so now we're going to share a couple of stories from that race. And here to share that first story, Stephen Rhodes.
All right. Is volume playing or not?
Hold on a second. Okay, that video does have audio, but he's going to talk.
Okay, so what this video is going to show, among other stuff, was just some of the things we had. Basically, so this was Impulse's first race that we brought to in Australia, and we made the decision to basically overhaul a large portion of electronics just a little bit before the race. So when testing over the summer, we found we had a few difficulties. So we replaced nearly the entire battery monitoring system and the entire electrical system going into Australia. And we were doing stuff like designing the boards while the car was shipping. We were soldering the boards in our hotel rooms. We were coding it as we were driving up to the racetrack. Yet somehow when we put it together, it all worked with just like a few minor glitches. Like the video that I wanted to show here that may or may not work was the funniest glitch that we had was our cable. Let's see if we can play it, okay. Actually.
So wait a second. So what you're telling me is that the waves
interfere with the measurements of the potentiometers, cause them to fluctuate enough to make the car move.
So what you're telling me is that our radios are literally controlling the car.
Yeah.
Is that supposed to happen?
No.
So,
No. Yeah.
Okay, what am I doing?
Can we try it again?
Okay, so it shouldn't have a problem.
Okay, testing.
Her foot is off the accelerator.
Testing. So whenever I transmit, it seems like it just keeps going faster. And if I keep talking, it keeps going.
Oh, there go my glasses. I don't care. Brakes! You have them!
All right, that was probably the funniest error we have. We actually solved that by just switching the wavelength of the radio, and all of our problems just disappeared. But again, the amazing thing is once we actually had the electronics working, we had one of the most reliable cars there. And I think Mike is going to come back and tell us a bit of the story about that.
Yeah, so as Stephen was saying, Impulse was one of the most reliable cars on the track. Before the race started, we were out on the track almost constantly, testing the car, because we didn't have anything to fix. We wanted to stress test it as much as possible to see if we could break it in ways that we weren't expecting. Now, that didn't happen until later down the road, which I think Nicole's going to talk about. But I wanted to show you this photo, which is a photo of the license plate that we received from the Australian authorities. So this license plate to us meant a great deal because it was a representation of the amount of work and a real culmination of the achievement that we had completed up to this point. So to be able to get this, we went through a process that's called scrutineering, which is an intense 2-day experience. The first day is called static scrutineering, where they go through every single little subcomponent of your car to make sure that it's safe, reliable, and not going to fail on the road in ways that are dangerous to the driver. So we passed that with flying colors, with the exception of a couple of stickers that we added. Following static scrutineering was dynamic scrutineering. And so, as its name implies, it is a scrutineering on the road to make sure that our vehicle is roadworthy. So that involves a hot lap around Hidden Valley Raceway, which is the racetrack in Darwin, and in addition to a stress test on a slalom course and a braking test, in which we had to stop the car in less than 3 seconds. So we passed that with flying colors as well, and we were given this license plate as a certificate of our authority, and it was also our ticket to go. So this was the only thing, scrutineering was the only thing at that point that was remaining to stop us from going on this race, and as we passed that checkpoint, we were ready to go, we were fired up, and we just needed to get out on the road and do it. So Nicole's going to talk about that.
So as Mike said, after the scrutineering period out on the Darwin test track, we began the week-long 1,800-mile race across the Australian outback. Now, the World Solar Challenge is truly a challenge. It's not just a race. We battled everything from dust storms to rain showers to a bushfire that closed down the highway for 4 hours. Now, the story that I really want to talk about is the latter period of the race. This third and second to last days of the race, of this week-long race, we had constant cloud cover and even some very intense rain showers that pretty much drained our battery pack completely. The last few hours of the second to last day of the race, we were inching along the deserted highway at about 11 kilometers an hour. We had teammates walking along the solar car, cheering it on. Every little incline that we had, whether it was, just a single degree, we were worried that the car wouldn't make it up. Every hill, once we got to the top, the entire team cheered for the car, which we dubbed at that point the little solar car that could. Finally, at 5 p.m., which is the official stopping time every single day, the car shut down on its own, as if it just said, "This is enough. I can't go any further." Then, the last day, the skies cleared, and it was so bright and sunny that you would have never believed it had rained for the 2 previous days. Even on an empty battery pack, we flew down the road at excess of 85 kilometers an hour just from the charge that we were getting from the solar cells in real time. At some points, we even raced a train, which honked at us as we went by. It was a really, really exciting finish for the team. We racked up as many miles as we could until the official race end, which was 11 a.m. on that Saturday.
Okay. Thanks, Nicole. So next up, after the World Solar Challenge, we went to the American Solar Challenge in the United States. So Jack is going to tell us about how that went.
Hey guys, so my name is Jack. I'm going to talk about American Solar Challenge, which we went to last summer. So after the car came back from Australia, we did lots of improvements to the car, mainly on the solar panels, and also we improved we didn't improve the efficiency, but we improved the reliability. So the car went on really nice, went to this American Solar Challenge. We started from Rochester, New York, and it's a 1,652-mile race. It's a 1,652-mile race, all by solar. And actually, we have 14 members, 1 month in field, and 8 days of racing, and all the race is on solar. And as you guys can see here, these are all the teams that participate in this race. And we are one of the 4 teams who finish all the race by solar. There in the race, there are lots of things like rainstorm and lots of other problems going on. And later on, people are going to cover about it. I think next one going to be Ryan. Yeah.
Now, in addition to the race itself being a challenge and a struggle for all of us to compete in, there's a lot of other issues that happen. For example, if you saw on the map, the race started in New York, so we had to get there. Clearly, we're in California. So it was 3,000 miles for us to be able to get all of the team, our equipment, the solar car, trailer. We had 4 vehicles with us. We had to get all of that from California to New York. In the process, we came across a couple glitches. We had one speeding ticket in the middle of Nevada. We had one minor fender bender. And there was also at least one replaced battery while we were there. What actually happened here was someone was running a 12-volt power supply off of one of the electric ports in the Sienna here. And I think it was for either soldering or we were doing some measurements. I forget what we were doing exactly. But the person totally drained the car battery completely. Couldn't start the car. And we had electrical engineers arguing about which order to put in to jump the car. we eventually determined that what we decided on was wrong because we looked it up online and connected up the right way. We had to hook it up for over 20 minutes just to get the car able to turn on because we had drained it so low. But I took this photo and I tweeted it on the CalSol Twitter page. And not half an hour later, I get a text from my mother. This is her car. I got a text from my mother, and she says, "What's wrong with the car?" And so I had to explain myself what happened to her car while we were gone. This is actually just an elementary school parking lot that we used for working on the car. But it was a lot of fun too, though. Like being able to actually get there. I mean, we had 6 days where we were actually traveling across the 3,000 miles. So we got to take the whole summer off, travel, go camping with all of our best friends. So we learned a lot from that. Like one of the things I learned was for 13 guys, how much oatmeal do you need in the morning to feed 13 guys so that you're not starving by 11 o'clock? You need the entire Quaker Oats can for 13 guys, by the way, and something to flavor it because people didn't like my choice of breakfast. But yeah, in hindsight, we had very few problems actually just moving everyone, this massive involvement. I mean, we had to move the farthest of any other solar car team out there. But we had very few problems, I think, in the end. And it's a great learning experience for us to be able to go on any future road trips or anything. So we learned a lot of life skills too, not just how to build a solar vehicle. But, and I think Jack is coming back up to talk about some other issues and successes.
Hey guys, it's me again. So before I switch to the next slide, have you guys think about why this thing doesn't, why sometimes the solar array doesn't work, and why sometimes your laptop may not starting, and why sometimes like the horn doesn't work? It's just not loud enough. So all these problems are not complicated. There are very simple reason for that: connectors. As you guys can see here, this is a photo of Ben repairing one of the connectors on the car. So for complex system, you guys may think like some complicated reason may be behind like some problems, like the horn doesn't get loud enough or the array is not outputting enough power. But actually, the most important thing is just a widely distributed but trivial problem: connectors. So you guys can see all these. If you guys can see all the wires behind, these are the connectors for the array. So the reliability of these connectors are actually extremely important for automobile vehicle like a solar car, or even for your normal cars. So if the manufacturer didn't build a connector to reliable enough, in vibration, you have a lot of vibrations going on, and all these connectors have certain factors of reliability. If these things shock off, and then increase the resistance between different connectors, and have bad signal integrity, and also or bad power transmission, and these things are gonna hinder the whole car from moving out. So what we learned from here is that when building a car, rather than focusing on the most difficult part, like how do we program the chips or how do we design the PCB board, we should also pay a lot of attention to the small problems, the trivial problems like the connectors. So yeah, actually we spent a lot of time on this during the race. And the reason why we can finish all the race is also because we made a connector, right? There's actually one team who made a connector run. They connect the positive terminal to a low voltage positive terminal to a high voltage battery pack, and then they fried their electrical system. But that's because the connector wasn't keyed. So in the next car, we are going to try much more on that. Yeah. Thank you. So the next one going to be, I think, Ben.
Hi guys, you may recognize me. I also want to start this presentation clean. I drained Brian's mother's car's battery, so I apologize for that. So hopefully this might make up for it. So this is a picture of me climbing into Impulse, and what I'm doing is actually I'm taking the radios out of Impulse in order to charge them for the next stage. Right now this is Ann Arbor. So previous members have talked about, some of the things that we need to do in order to, in our typical race day. And there are a lot of things that kind of aren't obvious to, to bystanders or spectators of the race. And I would have to say one of them is definitely race communications. It's very easy to overlook how critical caravan communication is to the safety of the race crew as well as to efficient operation of your typical race day. So throughout the race, I was in chase car, the car that is immediately behind the solar car, and that sort of serves as the base of operations for everything that's going on. And there's a complex series of radio networks that we communicate over in order to talk about a whole bunch of things. And over your typical 9-hour race day, I would say our longest radio silence lasted maybe 3 minutes. So literally from 9 a.m. to 5 p.m., we were on the radio talking about something or other. So you may ask, well, okay, what exactly are you guys talking about? Are you, just like, telling bad jokes or, what is it? So I actually have a list of all the different things that we have to talk about. Mile marks, making sure that you're on the right part of the road. Race directions, getting ready for the next left turn, right turn, U-turn, etc. Battery voltages, traffic conditions, the solar vehicle speed, road speed limits, road conditions and quality, weather and clouds, driver changes, food and meals, passing teams, race strategy discussions, and estimated times of checkpoint arrival and departure, and a lot more. So, once you think about it, you might not be surprised that we're talking so much. And actually, there's one incident in particular that I remember quite clearly, because as the chase car, you're the only one allowed to talk to the solar driver because they don't want conflicting communication coming in. And the lead car is only allowed to talk to race officials and other passing teams. So there's actually quite a lot of communication going on in the chase car. And actually what happened was we were coming up upon a team ahead of us, and there was a team behind us trying to pass us. So in this stretch of maybe, like half a mile, you have 15 different vehicles, and they're all trying to talk to each other. And in the chase car, we had maybe 4 or 5 people, and every single person was talking, but not to each other because they had some form of a radio or a cell phone up to their mouth. So everyone's trying to talk to someone, but they're actually all not talking to each other, and you have to communicate what's going on, and it's actually quite hectic. And the sheer volume of information that's trying to get in and out of that car is simply incredible. So that's something you should take into consideration when you see us scrambling around at a stage stop. Next up, I think we have Nicole or Arjun.
All right, so thus far, you've learned about all of our interesting stories going to Australia and across the country. And although we travel to many interesting places, I want to emphasize that we are students always. We are students of UC Berkeley, and we're students of CalSol. And although each day we work very hard academically, we do see value in struggling and working with real-world engineering problems. This here is a picture of several of our team members working at the Richmond Field Station, which is where we build and test our solar car. But for many of us, it is essentially our playground, because we love to come out here to go to work and build this car. Now, most university students, their average day entails going to class, then doing homework, and then calling it a night. But many of us CalSol members, after finishing homework, will then carpool as a team out to the station, far away from campus, and work long hours, and as this picture shows, all night building the solar car. And I think just going to somewhat of a rundown facility out in Richmond, yet still creating one of the premier cars in the nation, is really a testimony to our dedication and motivation as a team. And I think the big picture that we're trying to get across here is that it is really our passion each and every day that fuels and drives our solar car, along with the sun, of course. But I'd like to pass it over to Mike, who'll talk more about what it's like working on a solar project from the viewpoint of a student organization.
Thanks, Arjun. Before I go on, I just want to mention real quick Brian's story about draining that vehicle. Not only did he receive a text message from his mother, but then about an hour later, I received a call from my mother wondering why I was in the photo. She wanted to make sure that I wasn't the one that damaged the vehicle. So anyways, one of the other problems that goes with being a student is dealing with the 4-year cycle that students go through. So you enter college in your freshman year, and then you leave as a senior. Now, that creates a problem for us because as you think of a typical company, there will be a lot of the senior members that will be around for 5, 6, maybe even longer than that. And so frequently our leadership will change every 2 to 3 years. So one of the times that happened was immediately after we came back from the Australian race, the leadership team at that time went through the process of deciding who was going to be the next leadership team and then figuring out how exactly they were going to transition that. It went rather smoothly, and as you can see, we were able to find a massive number of people who were interested in joining the team. In addition to that, we deal with frequent attrition rates. I would guesstimate that maybe 50% of those people are still here today. At the same time, even 50% of that massive group is still a lot of people. I would estimate that we have maybe 30 to 40 people working on our vehicle today. So with all of that, all of these students that are working, we need to make sure that we keep our contacts and make sure that everybody knows who we are so we can get the things done. And so Min is going to come up and tell us a little story about her experience in the machine shop and how some of the other administrations has seen our club through the years.
Okay, so I'm Minju and I joined CalSol last fall. Last week, I just completed my machine shop training, which means that starting from now on, I have the access to one of the many machine shop facilities on campus. It was actually really funny because when I was introducing myself to one of the machinists in the shop, I told them, my name is Minju and I'm working for CalSol. And Mick, who's one of the machinists who's worked there for years and years, he was, trying to get to know everybody, all the new students. And when I told him that I was from CalSol, he says, "Oh, you're from CalSol? Now that group's got its act together. They know what they're doing. The students are fantastic. They're so hardworking." And it was really great to hear that because that's just a testament to how hard we work. So as mentioned previously, we are also just mostly undergraduate and a few graduate students working on this car. Our group roster it's quite massive. We have about 70 students working on this team, but about 30 people just consistently chipping away at one aspect of the car or the other. But the thing is, this is quite difficult, but extremely rewarding for us because at Berkeley, we're taking very difficult classes, mostly theories, which are just, lots of mathematical equations, lots of physical diagrams that may seem pretty meaningless, really. But when you actually apply it to make something, it makes the world of a difference because you see that what you learn on campus is extremely important. But when you actually apply it, it's just a completely different world where you have to think about all the things that you've never thought about in a classroom setting. So as we joke around, one of our last general meetings, somebody accidentally said that we are full-time CalSol students with student on the side, which actually I would say is pretty accurate. So now I'm going to pass this over to Brian.
In addition to being an engineering team, we have business members that work with us and working with companies. We've got electrical engineers and mechanical engineers. We even have a film major on the team. We've got all sorts of different people. But one thing that that's another interesting facet of our organization is that because of the cool things that we do, we get invited to really incredible events. For example, this photo was actually taken at the Shabbat Space and Sciences Center in Oakland. I don't know if you guys have ever been there. But we had a big display there on one of their large kids days where they had a bunch of elementary school students come out, and the kind of looks and stares that you get from kids and even adults that come up and see the car, and especially when they get to sit in the car, is a pretty incredible experience because you really get this feeling that we are having an impact on people. You guys have ever heard of the astrophysicist Neil deGrasse Tyson? He's actually given a tech talk here at Google before. He's a big proponent of NASA being a large governmental organization and how it can encourage children to really want to be involved in the STEM fields. I know it's kind of a leap for us to make, but I feel like in the kind of sphere of influence that we have in the Bay Area, I sometimes feel like we have a similar impact on the students that we're involved with. I mean, they come up to our vehicles that we've built, and they're really in awe by it. Sometimes they don't really understand what it means to be a solar-powered vehicle. Oftentimes their parents do. But both, all of the ages are really surprised that we've been able to build a vehicle like this. The kind of and this doesn't even stop in the Bay Area. This is actually a photo in Ann Arbor, Michigan. That was a stage stop in the middle of the American Solar Challenge. We had pulled over, and it was a public event, so anyone in the area could come and take a look at all the solar cars, pull in from the race during the day. And in this case, a mother and a bunch of children came up and started asking me questions about the car. You know, what's this wire do? What's that hinge do? And I ended up talking to them for well over half an hour. My throat was parched by the end of it because the kids kept asking questions. And they're always so curious about, everything that we have on the vehicle. And it really makes me feel good that our team has an impact separate from the fact that we're becoming, better students and people because of the project. But the kind of, public impact that we have on people is pretty incredible. And I think now we'll be moving on to Derek to talk about Zephyr, our next solar vehicle.
Hi, I'm Derek. So, given our experiences in the American Solar Challenge, we wanted to make another vehicle that was even better for the American Solar Challenge of 2014. So basically, over the American Solar Challenge, we discovered that there were a lot of things that could be improved about Impulse. We basically boiled it down to we wanted to decrease the weight of the vehicle by a lot, and right now our current design is about 150 pounds lighter than the 525 pounds that Impulse was originally. But we have 4 wheels in this new vehicle because it's part of regulations change, and we're going to keep and the kind of speeds that Zephyr will be able to hit should be about the same as Impulse, which is about 75 miles an hour. The kind of improvements that we're going to be making in this car are the suspension is now made out of 7075. This is aircraft grade aluminum. It's now half as heavy as it used to be. The chassis is also made out of aluminum instead of steel, and that is about a 35% reduction from what it used to be. The shell is going to be made out of prepreg material. This is carbon fiber epoxy that's already inside the material instead of doing a wet layup. So that will reduce the shell weight by about half. And we've also improved the aerodynamics of the car. So we've gained about 150 watts of power just by reducing the frontal area off of this car now. On the electrical side of things, we've got new microcontrollers that'll increase the reliability of the code. And we have also going to encapsulate our own solar cells that'll increase the reliability of the solar cells. And of course, as Jack said, we've got the better connectors to make sure that things don't come apart and stop the car on us. So,
okay.
Right.
Thanks, Derek. That was a brief summary of CalSol and what we do. Now what I want to do is turn into Q&A. These are a few topics that we have prepared slides for, but we wanted to turn it to you guys to see what you want to hear about. So we have information on both the electrical business and mechanical aspects of the car. We have a few more videos of our car from driving it in Australia. We have some information on our custom lamination of the solar cells that we're working on. I turn it to you guys. What do you want to hear? Solar cells? All right, Min. Come on up.
What would you like to know about solar cells? Well, I can definitely talk for a very long time, but do you have any specific questions? So we actually have a regulated list of approved solar cells because there are definitely lab grade solar cells that can hit ridiculous efficiency rate. But if we didn't have regulation, then the school with the most money to afford those cells would basically win the race. So how we chose the solar cells, which we are going to use SunPower C60 FinJ. So those are 22.5% efficient. And we are also going to encapsulate them on our own. How we chose that is basically we went down the list of the approved solar cells and chose the one with the highest efficiency. Oh, by the way, they are monocrystalline silicon cells, if you're wondering. Sorry? Oh, yes, yes. Uh-huh.
Yeah, so the question was, would I ever be able to drive a solar car? Is this something that I could buy sometime down the road? So Arjun actually, well, we've proven that you can actually build a solar car. It can be done. Arjun has more information about whether it's economically feasible.
So I think the answer to this is can be qualified into two parts. You won't find a fully solar powered car like Zephyr or Impulse are, and part of that can be attributed electrically because the sunlight is unpredictable, especially when there are clouds or rain. You don't get a constant source of sun power, and part of that can be attributed mechanically because our car is extremely lightweight, but domestic markets are showing signs to bigger, larger cars that are roomier. So you'll never find a fully solar powered car, but there's still significance in what we do because you will definitely find partially solar powered cars. Definitely, in terms of economic reasons, there's policy going towards the vehicle to grid connectivity, and having a solar panel on top of your car will allow you to charge your car into the grid and also preserve your battery life because you're not constantly charging and discharging. And also for policy reasons, a lot of cars and a lot of their fleet averages are trying to increase their miles per gallon. So if you can have added solar panels on top of your car, or if you can work mechanically to improve the aerodynamics of your car, you will see yourself going hundreds of miles in between your trips to the gas tank or to the supercharger station. So there's a lot of validity to what we do. Yes.
Yeah, sure, I can answer that one. All right. So the question is, how does the array on Impulse or Zephyr compare to the amount of energy that a Tesla consumes? So, not very well is the short answer. Impulse and Zephyr, their arrays generate somewhere between 900 and 1500 watts, depending on how much sun we're receiving. A Tesla, on the other hand, its motor is designed to consume about 60 kilowatts at full zoom. So, as you can imagine, at 60 kilowatt drain, our battery pack and our solar cells will not be able to supply that energy for very long. We have a 5.2 kilowatt hour battery in the car, and so as that compares to a Tesla, that's maybe 10% of it. The lessons that you can really take from building a solar car is less so the one of solar panels and how to apply them to cars in general, but more the lessons of efficiency gains. So when we take solar panels, we're really taking an efficiency challenge to say, can we run on the energy of a microwave? Can we run for thousands of miles at a time without stopping for gas or a charge? So I think for us, that's the real applications of this project. Yeah. Yeah, Brian, do you want to go into that?
Yeah, so the question was, what specific technologies or things that we do to make the car incredibly efficient? And I would actually classify our car as probably more like hyper efficient. The amount of power that we drain when we're actually transporting a human from point A to point B is the power of a hairdryer. At 40 miles an hour, which Impulse is break-even speed, that's power in equals power out, and we can go forever. Things that allow us to do that are the aerodynamics of the car. So the Model S, for example, has a 0.24 coefficient of drag, which they claim is the best for a consumer car on the market. The designed coefficient of drag for Impulse was 0.17. And for Zephyr, we've dropped it even farther to about 0.12, 0.13. 0.09, 0.09. Yeah, so I mean, we're continually dropping that number. That is being multiplied into the drag from the arrow, and so anytime you get a percent drop in that, you're getting a percent drop in the force on your car. The lightness of our vehicle has a big impact. The lighter your car is, the less rolling resistance you'll have, paired with the choice of tires that we have. For example, even looking at the Model S again, they'll have big, wide tires. A lot of that is for the performance. If they want the grip from the car to be able to go around a turn. We have more like moped tires. Kind of like oversized bicycle tires almost. And they're at like 80 psi. So really high tire pressures, you don't lose a lot of energy to that just pure rolling resistance. And this car will coast forever. We actually took this to the Alameda airstrip. Sometimes you might be able to see it on Mythbusters if you watch that show. We did coast down testings on there, and we coasted from, I don't know, like 55 to 30 because over a mile. Because you just don't lose speed very well in this vehicle, and you don't need a lot to get it going. You don't need a lot to keep it going. But also just electrically is another thing, is that if you really pinpoint where your power losses are, whether it's through heat, whether it's through headlights or turn blinkers, or you always choose electronics that are very low power. What's the kind of standing power usage? Below 70 watts to be able to just turn on our car and have it running. So you take the rest of that, 900 to 1500 watts. We have all the rest of that to be able to charge our battery pack or use it while we're driving. Those are kind of the main ones that we do, and most of the design choices that we make fit into those categories. Every part that we design, we really pinpoint, every gram, every ounce of weight that we can take off of it, because that means it's less weight that you're carrying around for every mile that we drive. Any other things? Yep. The question was, what's kind of the number one, number two things that we wanted to change from the last car to the current car? I know, what would be good ones? You want one? Okay, go for it.
So I'm the solar lead, and for the first time in CalSol's history, we are going to encapsulate our solar cells on our own. So to just a little more history about that, yeah, sure. Yeah, go for it. So, thing is, another thing that we haven't talked about throughout this presentation is that building this car is extraordinarily expensive. The good thing is we get a lot of companies to either sponsor us with money, with financial means, or with the actual materials. So we don't actually have to take the hit on our own, which has actually worked out quite well over the last decade or so. But something more, just give you more breakdown of the cost. Previously, we bought our solar cells encapsulated, and that cost $25,000. But mind you, the solar cells themselves should not cost more than $5,000, which means that the encapsulation cost $20,000. And if you think about it, that's pretty atrocious because you're just putting on essentially like a laminate, like a film on these solar cells, and that costs $20,000. Like, that's ridiculous. So what other solar car teams did is that they actually just encapsulated the solar cells on their own. But of course, this is really tricky because that was actually the project that I received when I first joined CalSol, is to figure out if you can encapsulate the cells. You have to do a little more than just putting on a little coating. You have to think about like the optics, the properties of these materials, and also how you're able to apply these laminates onto the cell. But over the last few months, we deemed that it would be possible for us to try encapsulation. So hopefully that would save us about $20,000 is the goal. But of course, my solar sub team and I are still trying to figure out and fine tune the process of encapsulation. We have a couple of bare cells that were left over from the previous model. So we take those and we called up DuPont and the other material suppliers to ask for samples. And we've tried various things like just pop it in an oven and see what happens. Some have been quite disastrous, like they come out looking like a popcorn, but this one was particularly successful because this one we actually used a heat gun. We had a temporary lack of an oven, so we were trying to be really creative with it. Hey, heat gun is kind of more or less the same thing. It's hot, right? So we just heat gun the solar cell, and it actually worked really, really well. Of course, we're not going to heat gun all 400 cells that will be on Zephyr, but it's the idea. So right now we're doing R&D of the solar encapsulation, and it's working quite well. But it will definitely be a big challenge seeing that we're doing this for the first time in CalSol's history.
Thanks, Ben. I just wanted to answer the question a little bit more directly. There were two big problems that I can think of when I think of issues that we ran into. The first one being connectors. And Jack went into that a little bit, but it actually ended up being one of the main problems during the World Solar Challenge. The first day we were out there, we had one of our connectors fail, and that meant that we weren't getting power from our array for over 4 hours. Now, during that day, that meant that our pack, our battery charge state went from over 100%, exactly 100%, I shouldn't say over 100%, to close to 50%. And now that charge has to be our essentially emergency rations for the car for the entire week-long event. And so that caused a lot of problems, and in the future we're going to make sure that all of our connectors are well tested, manufactured well, and to make sure that they're capable of withstanding the weather. Now that alludes a little bit to our second problem, which is manufacturing issues. Impulse was in a lot of ways a first run in a lot of new materials. It was our first time using carbon fiber composites in several years. And so a lot of the students that had worked with that materials previously have been graduated. So really what we are doing, and because of that, and because of time constraints put in place by the race, we made some errors in our carbon fiber layups, and that caused the car to be about 100 pounds overweight, in decreasing our efficiency overall. Yeah. We will be racing again in the American Solar Challenge 2014. So that'll be July of next summer. Yep. This is this car. So right now, actually, for this car, we just got back our mold for the carbon fiber, and over the next couple of months, we'll be creating the shell. Yeah. Yeah, Nicole will talk about the pre-preg experience a bit.
Yeah, so I'll just address a little bit more of the manufacturing issue that Mike talked about with our carbon fiber. So as Mike said, with the previous car, we had the problem of lack of experience of how to really deal with carbon fiber manufacturing technologies. And so as you can see, this car is a very streamlined aerodynamic shape, but we don't use an aluminum punched out frame like a lot of the normal cars do. We actually use carbon fiber composite materials because of the improved strength to weight ratio. And so what we do is you machine out a mold, and then you do a carbon fiber layup where the carbon fiber weave, and then you add epoxy to that, and then you cure it so that it stays in the shape of your car. Last time around, the molds that we used were made out of fairly cheap styrofoam, and the coating process that we had was not sufficient to pull vacuum on this thing. And so we were unable to pull vacuum and had to do a lot of hack fixes in the end to get this thing to be stiff enough to support the solar cells and not flop around. And so in retrospect, looking back on it, we've done a lot more research and we've looked into things. And this time around, we're planning on using pre-impregnated carbon fiber. So the carbon fiber comes with the epoxy already in it, which has the benefits of improved weight ratio because you use just the amount of epoxy that you actually need instead of accidentally spreading over more than you need. And it also gives you a longer working time with the carbon fiber. So the epoxy that we used last time had about a 2-hour working time in normal weather conditions. We made the mistake of doing it on a day where the temperatures reached about 80 to 85, which meant that we had about an hour and a half tops working time. And this is, so just to get kind of the dimensions right, this car is 5 meters long. I know it looks a little small on the screen, but it is 5 meters long and it's almost 2 meters wide. So that is a lot of area to cover with this carbon fiber and make sure that you get everything in the position where you need it to be, then put it on the vacuum bagging and then pull vacuum on this thing before it starts to cure. And so with the pre-preg, the added benefit is that we have, I think, a 3-week working time if we needed it, which means that we can really plan out every single cut, every single layer of where this is going, and we'll have enough time to really make this car as optimal as it can be. We'll really have the time and the knowledge to put all of the layers where they need to be, not put extra material, not add extra epoxy to make sure that these things don't delaminate, that kind of thing.
Thanks, Nicole. Any other questions we can answer for you? Yeah. Yeah. Yeah, so we make an effort to welcome every student that's interested in joining. Right. The question was, you go into the organizational structure of the team a little more and the difficulties within. So we try to cater to anybody who wants to join the team. And one of the first things that we do with them is that we take them through a relatively short training program to get them up to speed, make sure they know the different aspects of the car. From an administration standpoint, we have, I'm the team lead, and there's a couple of levels. We split our entire team into 3 different major teams. So these are the business teams, the mechanical team, and the electrical team. Within each of those, within the electrical team, we have 5 sub-teams working on different aspects of the car. So one is working on human-car interface, one is working on the data collection, and a few others. And the mechanical team as well is broken up into 5 different aspects. So things like the suspension, the chassis, the motor, the shell, and a few others. So from an administration standpoint, it becomes tricky to be able to manage so many people. But with the structure that we've set up, we're able to make sure that there's one person that's able to have a very good idea of each subsystem of the car. And from there, we're able to build a very good working knowledge of everything that's going on. It's almost completely undergrads. We do have one professor who is there so we can be officially affiliated with the university as much as we can be. And then there are a few grad students that participate as well. Right, exactly. Any other questions we can answer? It's a good question. So the question was, how do we pay for this? It's a very interesting process, and that I think Arjun would be best to answer.
So just quick clarification. I'm the business lead. So the way we kind of fund this car, Zephyr itself is going to cost about $200,000 to build and about $50,000 to race. So the way we get our money is pretty much entirely through sponsors. Because we work at a public university that is already facing its own budget cuts, we need funding from outside companies. And so we really look for sponsorships, either in kind or in monetary, and then we go out and buy the raw materials so that the mechanical and electrical teams can then build the car. Yes. Is Google a sponsor? No, it is not. Yet. Any other questions?
Yeah, maybe we can play one more video from the race, and then you can mull on it a little bit. In case I wasn't clear, that was Stanford we were passing on the track there. Okay, well, thank you for your time. Thanks for having us out here.